Picking up where we last left off, I was wandering through my test, and it looks at this point that I've got my degenerate test cases sorted out. I'm not doing anything with this object that I'm passing in this null yet, so that's a good spot to check. And it looks at this point that I will need to start doing something with this HTTP response code. So that's, I think, where I left off. And that will be me diving right back in case you were lost. This is the making of ToMakeItGo. At the moment, I am looking, it looks like I'm going to be building an object that walks arbitrary class structures and announces what it's seen to a listener. Very much like a SAX parser of old for XML. Okay, well, let's get back to where I was. So now, do all these tests pass? Run the tests, see, let IntelliJ do its building. See if I can auto hide that. That's the task manager. Taskbar settings. Excellent. All of them do pass. Okay. Okay, tests pass. We just need to run a failing test. Let's call it with that guy. Try to do test method. We will say test listener receives HTTP response code, which is what seems reasonable. Turning on my timer because I didn't do that, and it's not much of 30 minutes if I just make up a time. Okay. There we go. My tomato timer is starting. Hey, look, I misspelled receives. Okay, just for the record, IntelliJ's autocorrect is awesome. I'd look like an illiterate fool without it, but back to what we're doing. Okay, so we're gonna need a new one of these dudes. No, we're not gonna run anything. Response. Let's take this. Make class. Excellent. It's a private static class. It's got lots of stuff on there. That is one ginormous import. Just add a static import to clean that up. Okay. Well, now this guy needs some methods. So let's give him void say visit. Well, I'm just gonna say set for now. It's not the right word, but it's close enough for what I'm thinking. And this is just an integer. Let's just bind that to field. There we go. Give ourselves a getter. Now, pull this guy up. Listener. So we're going to assert that listener.get HTTP code is what we expect it to be. That's a simple test. I think that's the next step we should walk. My keyboard's being a little goofy right now. I'm going to fix that. There we go. One of the little legs was higher up than the other one. It was rattling when I typed. It was bothering me a bit. So I fixed that. Okay, so there we go. Test listener receives HTTP response code. Well, look at that. It was null. Someone should do something about that. Okay, where are we in this walking, dude? Okay, at this point, we know that we have one. So, we also know that we have a listener. Listener dot HTTP to walk class dot get annotation. We know what it is. Lots of value. Excellent. That should make that pass. And so it does. Okay. Next test. Beautiful. It'll look real nice when we're done. Okay. So the next thing we need to do is we need to announce that we're entering a success object. So our listener is now going to need void enter object. That is going to take a string object identifier. And we're also going to need a void exit object. And for, well, first we'll make sure that I respell identifier correctly. And then we will grab that guy and put it at the same signature. So we can enter an object, we can exit an object. So if we go back to this guy, it will all fail. Okay. There you go. So we expect HTTP response code. Entering object success. Exiting object success. Okay. Now, I want to keep track of those in a linear fashion. So for my test purposes, I want to be like A, B. I want to say something along. So we'll throw this into a list. Yeah, a single list of these guys. So part of my list of string. Entries equals new. Let's use an array list. That's a good list. I could use a linked list. I'm only actually adding to the end ties. I guess that is how you'd spell entries, because YS would just be funny. Entries. Yeah. Tries. Okay. Sometimes I just can't process how English works. Okay, a linked list always adds to the end, so it's first in, first out if I was pushing and popping, so it'll be in the right order. Okay. Alright, array list. A linked list does the exact opposite, always adds to the head, so if I was reading it, I'd be reading it backwards. It would be exit entry. Or, yeah. In this case, it won't matter. Let's actually preface this with enter object. And then exit object. That way I can be all like, hey, assert that entry, exit, entry, yeah. You know where I'm going. I hope, anyways. If you don't, no one will. Okay. No one, I don't even know if anyone is out there. Test. Enter base level. Enter object. Exit. Object called. With an identifier. With the identifiers. If the identifier fires string. Value is probably the more correct word because saying string doesn't particularly mean anything. So grab this. Grab that. So now at this point I should be able to say listener dot let's get. I don't have a getter. Add a getter for my dude. I'm gonna return a new one of those because I'm gonna wreck that thing up, and I may have to eventually call another one. And a copying an array is really light because it's just a game of, well, it's not really light. It's just a pointer game though. Okay, so listener. So step 1, assert at entries dot size. I would expect it to be 2 in the ideal world. Right now, it's probably going to be 0, but I need a failing test. Okay. There we go. Now, listener.enterObject. ToWalk.getAnnotation. Sorry, ToWalk class.getAnnotation. Okay, so we're going to grab the annotation. After I grab the annotation, I am going to grab its value. I'm going to put, then I'm going to enter exit. Exit object. There we go. That should be me entering the object, exiting the object. Go. Beautiful. Our tests pass, but do they do what we expect them to do, what we would want them to do? So now, let's write a little helper function now. Private void assert enter. We're going to have string value. Well, no, identifier value. Trying to give the next guy as many hints as I can, preferably ones that are, okay, so assert that, and we're going to give him the list. Assert that entries dot. Okay, at this point I might want to use a linked list because this has just got heavy. Because, well, heavy-ish, I guess. Because removing the 0th element in a linked list caused the whole linked list, or the whole array list, sorry. Removing the head of an array list, the first element, or the 0th position. Why we chose all these indexing problems to talk to the strangers with is just beyond me, but okay. So we're going to remove the 0th positioned element, and we're going to compare it to that value they gave us. So that way we can just assert, and we'll have a nice little, it'll walk the tree in a linear fashion, and that way I can see if it's how I expect it to be walked. So this will be like walking in the canonical root way. Okay. We also need to go take these tokens and duplicate them up here. So now, let's write that test. Assert enter, and I expect it to enter success. Wow, you can't, that's not how strings work in my language. And it's going to take my entries. Okay. It's going to pass, I think it'll pass. Okay, let's add this to see if I get an even remotely usable error. Okay. So it's a hand press answer. So traveling assertion error, expected enter object success, but was enter object success. Okay, that's good. We're gonna write another one of these little helper functions for exit. It's gonna be exactly the same. And at this point, you may be screaming at me because I'm passing in a list and then modifying it and continuing on with my way. I know I did that. That's okay. At least I think it's okay for the moment, what I'm trying to do. Because now I'm going to say, well, I can always go 0. I could do it up front either way. That'll modify the list. But now I get a, I expect a success, and our enter, so I expect I enter success and I exit success in that order. And okay, we'll run the test. Oh no! I agree, I used the wrong constant. And I may actually want to put this prefix, enter exit prefixes in a public static, so that way I can share them. Okay, but for now, I'm not going to care about that. I think we're just going to grab the 2 string values off of the object for that. Okay. Now, I expect ID and reason to be visited. So what order do I want them to visit it in? Because right now, if I just go grab all the declared methods off of sample response, I'm not guaranteed the order in which the methods come back to me in. And that can be actually vary based off of compile time. So one test run would fail, one would pass, depending on how I decided to compile the class file and store the order of the methods. So I'll have to sort them using some sort of criteria. Would it be, I kind of want to sort them off of the alphabetness of the identifier. I'm just trying to think if that would look a little goofy. Yeah. So what if it looks a little goofy? So yeah, I'll go grab all the declared methods with my identifier annotation, sort them based off of the value of the ID, and then walk them. I like that. Yeah, there we go. That'll be my canonical way of walking that. So, step 1, I need something down here, like enter. Okay, let's call them primitives. Well, yeah, primitives will work. So anything with an identifier that's not another not annotated with identifier or an annotation, I'm going to call it primitive. Okay, so down here, yeah, okay, as I define more nonsense, let's come up to this dude. So he's got an enter object, enter exit object. He's going to get a void, enter primitive. Okay. We're going to take the string object, method identifier. A primitive will always be a method, because what else would it be? It's not a class. If you're a class, you're clearly an object. And you're always going to be on a method. An array will always be on a method. So now we're going to ask him to format the, let's give it the object value. And we will also give it a class of return type. Method return type. Because it's going to be up, well, I'm doing that because, for example, if I walked an integer and I want to render out JSON, I need to know it's an integer, otherwise I'm going to render it out as a string. Same with Boolean. And if I don't, I'm just going to be wrong. And then we're going to give an exit primitive. I'm just going to copy and paste that because apparently my typing ability is just failing me. The reason I am keeping the method identifier in both the enter and the exit but not the value is because at the moment I need to, well, if say I decide to go and crazy and expand this to, say, XML, which isn't unreasonable of me to want to do in the future. That way I can render out the close tag without having to store the state of my previous tag. And I have the data. Look, it was right here. It was easy to find. Okay. Moving on. Back to my tests. So, now. Okay. I have a decision to make now. We now need to come up with the canonical way, or my test way of phrasing this. So, let's entries dot add. I wish I could spell. That would be awesome. So at some point in the future, I will learn how to do that. Make a note. So enter primitive, we're going to give them the method identifier. We're going to give them value. And we're going to give them the method return type. And we're going to use the simple class name, I think. Yeah, the simple class name would be method return type dot get simple name. If I got the full name, it would include the class path, and I don't ever want to have to type that again. And for this one, it's just going to be this. No, entries dot add that. And it's going to be exit, not enter. Okay, so I'll need to make another 2 test helpers to mirror that. Okay, seem reasonable? I think it is. You may disagree, but I can't hear you, so your opinion isn't as valuable as mine. Taking a drink of my tea there. Hopefully it's not horrifyingly annoying to you on the other end. Okay. Okay, I'm tempted to put these 3 things into a method and expose it as a static method off of this so that I can call it up above. I'm going to do that because that just struck my fancy. Yeah, put it in this guy. Enter primitive. Primitive. I might be the primitive. Enter primitive. What's this? It's weird that IntelliJ wanted to do that. We're just going to not give it the this. So the this, it would assume that I'm an inner class. If I took off static, that would have worked. I'm iterating that because I'm not sure how many people have actually played with inner objects that are not static. I don't prefer them, so I can do this. So dot this. So that says grab the class that I got constructed with and execute it, but I'm not going to care because I'm not a static. I'm going to be a static class, which means I'm my own man. I don't carry around my parents' class as baggage. I'm going to do the same thing for exit primitive. Exit primitive. Weird that IntelliJ keeps doing that. Exit primitive. I'm going to put that down here. There we go. So then we can assert enter. We're going to make that assert enter object. Assert exit object. Making my asserts enter. Okay, so I'm going to need my string it up. I'm going to take the 3 things I need to call that method. I really wish I could type. It would make this go faster. So this episode is the episode in which I lament my typing ability. That's a lie. They're all that episode. I'm going to take an object value. And then I'm going to take a class of some arbitrary type, method return type, and we're going to grab this assert. I'm also going to take entries, abstract list. That's an interesting decision. I guess the only thing it's was. And I'm going to make that a string. Yeah, now you're just thinking, well, maybe you should just stick to using his IDE to spell and type for him. And you're right, I should. Enter primitive method identifier value. And I put those in exactly the wrong order. Thanks a lot. There we go. Now, exit primitive is going to look exactly the same. Except it's just going to take the list and the identifier. And there we go. Okay. Now, let's expand this test. It says it's red. Run it. Because I just wrote a bunch of code and I didn't have red tests. And oh no, I'm feeling shamed. New test. Test primitives on base object are locked. Okay, so now we're going to hit the exact same thing as before. Then we're going to have one of these suckers. I believe ID. It's going to be a 0. And I think, oh, it's lowercase I, which means it is integer dot type. Now, and I need entries. And this should be 4. Which means I have way too contradictory tests. Yeah, I'll fix that in a bit. Okay. Well, I'll grab this dude, reason. He's a string. A fine response. You are a fine response. And we say exit primitive ID. I don't know that I may actually make an object so that I don't have to, or create an object off of this, and I can just walk, enter object, exit object, make sure, and then chain off of it, so that I don't have to pass this around everywhere. I could also just promote it up to my field variable, but I don't want to do that. Okay, so at this point, it should fail. Because that list is 2. I have a test proving that that list is 2. Okay, so now I have 2 contradictory tests. The easiest way to make them everything fail. Okay, not making everything fail. We need to gather up our declared methods, check to see, or collect all the declared methods that have identifier on them, and walk them. That's doable. Step 1, walk class.get declared methods. Look, we got them all right there. Okay. Step 1 is now to walk it, or to filter that list down, and then sort it. So let's iterate over those of them that are declared methods. List. I'm in Java 8, aren't I? Am I? Stream? Streams? Stream util? Am I in Java 8? To my build file, because if I'm in Java 8, I could do all sorts of cool things. I have to remember... Okay, I have to Google something because stream builder stream of. There it is. Found it. Step 1, filter. I don't have any Maven projects. I apologize for opening that. Okay. Are you guys ready for this? I'm going to be all like, class, : is annotation present. Ooh, I can't. as being so cool, but I can't do it. We'll just have to method enterprise presence. I think I can. Let's see if IntelliJ gives me a. Okay, it didn't, so we filtered it. Now we need to sort it. One dot get annotation. Dot class. You dot compare to. I'm okay doing that because we learned in a previous episode that you can't put null in those. Get annotation. That is much nicer. I should have done that in the first place. I'm going to. Comparing. Sort it, compare it. And now, let's for each of them. For each, we have a listener. I'm going to have to do that because I have multiple code block. I have multiple lines. Listener.enter object. Enter primitive. Method.get annotation. Okay, we're gonna call this method invoke. We're going to invoke the method on walk. That is the object I will be invoking it on. I will surround that with a bunch of try catches. And I will method get return type. Now I will look at see why this is mad at me. Because there you go. And now I will listener.exit primitive. I will finish up with this to make sure my tests pass. Before I leave you, that was my timer saying that my time is up. I have spent too long in this tomato timer. However, I want to see the tests pass because I think I have written all of it. Things I need to do are print a really good, throw an exception that means something off of that. Although I don't like throwing exceptions out of streams. In the next episode, you will watch me fret for hours over how to handle that error. Let's see what my tests say. They're all like, you suck at writing Java code. To which I respond, nuh-uh. I know what I'm doing. And this is when the audience at home starts laughing. Run my test. Whoa, I got 6. Yeah, I did get 6. 1, 2, 3, 4, 5, 6. Bam! Now look at that. So aren't streams amazing? Except now I have this guy that's failing because he expects 6 as well. And now he will expect some sort of consume operation here. See? Because he entered the primitive, he didn't enter. So, entries. Dot consume. Remove. And I do that 4 times. I will build a helper function for that. I said for I. There. And there you go. I shall leave you with all my tests passing. Ta-da! Okay, the next step is, in this object, to make it handle arrays and nested annotated objects. But for now, I have all my tests passing. I have written some code. I have introduced an edge case that I have not tested, which is what happens when one of these methods is private, or the security manager explodes at me. This bit right here that I just expressed. So this is if it the invocation target exception is if it were to throw an exception. So I called a method that didn't exist, which I might have. I did just sort of invoke it. And the illegal access exception is if it was private, it would throw that. Okay? Now, this has been a wonderful episode. Thank you for watching, and I hope you tune in for next time. Farewell. This has been the Making